Hey there, you 8s, Mr. Herman here, and this is exercise 3G, converting fractions, decimals, and percentages. Learning goals for this one is to understand that a percentage is a number out of 100. And the success criteria is to be able to convert percentages to fractions and decimals, and to also be able to convert fractions and decimals back to percentages. So percent, we've all used percentages within maths and within the outside world of school. Percent is just Latin for out of 100, and you know the word cent sprouts from a Latin word which means 100. So $1 equals 100 cents, and 1 century equals 100 years. We come across percentages in many everyday situations, such as interest rates, discounts, test results, and statistics. They're just to name some common ways that we deal with them. So percentages are closely related to fractions. They have the most closest association with each other. A percentage is another way of writing a fraction with a denominator of 100. So therefore, you can say that 63% means that if something was broken into 100 parts, you would have 63 of them. So 63%, another way of writing this, is 63 over 100. Now, before we get to different examples, I have to show you the processes of how to deal with the conversions. So remember, the simple percent just means per century. That's where the word percent comes from. It's actually two words put together, per century. And again, it comes from the Latin word per centum, which translates to out of 100. So in this example here, we have 23%, and there are two formats that we can show this. In fraction format, which is 23 out of 100, and word format, 23 out of 100, or decimal format, 0.23. And we're going to find a look into the skills of how to convert from one to another. To convert a percentage to a fraction, all you need to do is change the percentage sign to a denominator out of 100, just like we saw in a previous example. And then, if possible, simplify that fraction. So example, 35% is the same as 35 out of 100, which can be simplified to 7 over 20 because the highest common factor in this case is 5. 5 goes into 35 7 times, and 5 goes into 100 20 times. To convert a percentage to a decimal, you're just going to divide that percentage by 100. And therefore, we're going to move the decimal point 2 places to the left. Remember, when we divide, it's to the left, to the left. Every single time you divide it to the left. Little Beyonce reference. I'll show a picture of Beyonce right here. So for example, 46% is equal to 46 divided by 100. And again, you just move the decimal place to the left twice, 1, 2. So it becomes 0.46. The second and last one is to convert a fraction to a percentage. And all you need to do in this case is multiply by 100. So for example, 1 over 8, and to convert this fraction to a percentage, it's 1 over 8 times 100. And remember, 100 is just the same as writing it as 100 over 1. Because how many ones go into 100? Well, 100. So to convert this into a fraction as well, to make this fraction multiplication easier, it just becomes 1 over 8 times 100 over 1. Now here we've done a simplification of 25 over 2, and there's this important step of getting from this here to 25 over 2, which I'll show you the intermediate step when we do an example. 25 over 2 simplifies as 12.5. So 1 over 8 is equal to 12.5%. You can also write this as 12.5%. And lastly, to convert a decimal to a percentage, again, you just multiply by 100. Therefore, we're going to move the decimal point 2 places to the right this time when we multiply. So for example, 0.812, to convert that decimal to a percentage, you just multiply by 100, which is 81.2. So 0.812 is the same as 81.2%. Generally speaking, when you're converting a decimal, we deal with percentages from 0 to 100%. Generally speaking, when we're comparing a quantity to another quantity, where the numerator is smaller than the denominator. In this case here, we expect, if we're dealing from 0 to 100, we expect the decimal number to be from 0 to 1. So 0.812 is in between the numbers of 0 to 1. In the circumstance when you have a number greater than 1, you'll still apply the same rule, move the decimal point 2 times to the right, but in that case the percentage will be greater than 100%. So just keep this in mind when we tackle the set questions within the examples. Now here we've got a table of common percentages and their equivalent fractions. This is shown here, and it is helpful to know these. And obviously the easiest ones to remember is half, because we know half is the same as 50% or 0.5 as a decimal. 1/5, known as 20%, 0.2. 3/4, 75%. And 1/4, 0.25, 25%. These are the most common ones. 1/8, 12.5, which you just saw before as well. The 1/3 and the 2/3 are the ones where it's actually quite tricky to think of it as a percentage, because technically it's 33.333333% or 66.6666%, etc. Again, you can familiarize yourself with these, and it's handy to know these. In this simple case, most of these have the numerator of 1, except for 2/3 and 3/4. Alright, so first example 21, we are going to convert the following percentages to fractions or mixed numerals in their simplest form. So the first one is 160%, and the second one is 12.5%, and we're converting it from a percentage to a fraction. So we're expecting some number over 100 to begin with. So 160%. Now this is a circumstance I was talking about before, where the percentage is greater than 100. If we were to convert this to a decimal, it would be greater than 1. If we were to convert this to a fraction, we're expecting a fraction with a numerator bigger than the denominator, so it's going to be an improper fraction. And we just convert that to a mixed numeral. So 160 is the same as 160%, rather, it's the same as 160 over 100. Now to simplify this, there's a neat little trick. If both of the numbers end with a 0, you can cross these out. So in other words, this will cross out with this. So this is the same as 16 over 10. Now this is assuming that both of them end with a 0. Okay, so this is a little hack. So a little side note, which I'll write here. If it was 1600 over 1000, for each 0 that you see, you can cross them out. So it can go like that and like that. So this is equivalent as 16 over 10 as well. So this here is the same as this here, which is the same as 16 over 10. So this is a neat little hack if you want to know for next time. This only works with zeros. It doesn't work with other numbers. So you can't just simply see a 2 and a 2 and just cross them out. Only with zeros, and only if there are no decimal points within the numbers, numerator and denominator. Now 16 over 10, I know that this 2 can go into both of them. So let's divide this by 2 and divide this by 2, as my highest common factor in this case is equal to 2. So 16 divided by 2, this is equal to 8, and 10 divided by 2, this is equal to 5. So this is the improper fraction version of this, and then we just simply turn this into a mixed numeral. How many 5s go into 8? 1, with 3 remaining. So 1 and 3/5 is your final answer. So this is just saying 160% of something is the same as getting 1 and 3/5 of that certain thing. B, 12.5%. 12.5%. To convert this, again, 12.5 over 100. Now we're in a situation where there are 2 ways that we can tackle this. The way that I prefer is whenever we see a decimal within a fraction, this is actually deemed quite unusual. We don't usually see decimals within fractions. To compensate for this, I'm actually going to turn this into 125. Or in other words, I'm going to multiply this numerator by 10. So I'm forcing this decimal place to go 1 spot to the right. But as I do this, as a consequence, I'm also going to multiply the numerator, the denominator by 10 as well. And 100 times 10 is 1000. So now we've got 125 over 1000. This is the same as 12.5 over 100, but the only reason why I want to do this is it makes it easier to simplify this, because we don't want to avoid these weird decimals. So 125 over 1000. Now this one is not obvious. The highest common factor, or one of the factors I can think of, is 25. So I'm going to divide both of these by 25. by 25. How many 25s go into 125? This is equal to 25, 50, 75, 100, 125. So this is 5. And how many 25s go into 1,000? 25, 50, 75, 100. It goes into 104 times, so it's bound to go into 1,000 40 times. Now again, this can be divided again. So let's divide this by 5 and divide this by 5 because it's another factor of 5. This is equal to 1 over 8. So 12.5% as a fraction is 1 over 8. The next example we're going to look at is converting the following percentages to decimals. So A is, there's a bit cut out there, so apologies, there's a little textbook error. 723%. So when we're converting a percentage to a decimal, we're going to be dividing this by 100. So we're going to divide 723 by 100 to turn it into a decimal. And in this case, we're just moving the decimal point to the left twice because there are 2 zeros. So 723% is the same as 7.23. 13.45%. We're going to do 13.45 divided by, and it's always 100, divided by 100. Move the decimal point twice to the left. So this is going to be equal to 0.1345 as a decimal. Notice that with this percentage here, this is greater than 100, so I'm expecting my decimal number to be greater than 1. In this case it is 7.23. But with the number between 0 to 100, namely a percentage between 0 to 100, my decimal number will be between 0 to 1, which it is, it's 0.134. So no, I'm doing this process both correctly. Alright, we're now getting into trickier territory. We're going to convert the following fractions and mixed numerals, which we can see here, into percentages. Alright, so to turn it into percentage, it's so easy to grab the calculator, do 3 over 5 times 100, and let the calculator do the rest. But we want to be able to do the skill without a calculator. Now, a little side story, I have had students come up to me and tell me that this is one of the skills that they wish that they further developed once they left school. It was a skill that they wish they had further developed because they've been caught out in a position where they needed to convert a fraction into a percentage and they didn't have a phone or a calculator with them and they were put on the spot and the boss kind of expected him to do it. I've had 2 stories of this actually happening. So trust me, this skill is worthwhile to know. Chances are 99% of the times you will have your phone on you or some type of calculator within your phone, and you can just simply do this on there. But that 1%, if you get caught out, it's good to have this as a backup. So 3 over 5 times 100. Remember, this is the same as 3 over 5 times 100 over 1. Now this turns into 3 times 100 is 300. And this 5 times 1 is just 5. And so effectively what we're trying to find out is how many 5s go into 300. So 5 into 3, I'll just put this up the top here. I'll make some room for it here. 5 into 3 we can't do. 5 into 30, 5, 10, 15, 20, 25, 30. This is 6. And 5 into 0 is 0. So this is 60. Now remember, we're changing this into a percentage. So my final answer is 60%. And that makes sense. 3/5 is the same as 60%. Because if we have 100 of some sort of a quantity, and we were to split this up into fifths, this is 20, 20, 20, 20, and 20. 3/5 of them are 20, 40, 60, which is 60%. That makes sense. So just keep that in mind as a visual. I thought that was a pretty nifty thing that I got shown when I was younger to better understand percentages. For B, we are going to do 7 over 40. The 7 over 40, we're going to times this by 100 over 1. I'm just going to go straight into it. So this is going to be 700 over 40. 7 times 100 is 700, and 40 times 1 is 40. Remember our cool little hack. Whenever I see a 0 on the top, I can cancel it out with a 0 on the bottom. I said bottom, that's weird. Alright, now we're just trying to figure out how many 4s go into 70. So 4s into 70, 4 into 7 is 1 with 3 remainder. 4 into, should put that here rather, 4 into 30, 4, 8, 12, 16, 20, 24, 28, that is 7 with 2 remaining. Because we have no 2 remaining to put there, let's put a 0 here, 0.0. 4 into 20 is 5 with no remainder. So remember, this is a division skill that we worked on before in our previous exercises. So 70 over 4 is the same as 17.5%. For C, we have 2 and 1/4. Now, I can't do this, multiply this by 100 without converting this mixed numeral into an improper fraction. So to turn this into an improper fraction, we know it's going to be something over 4. We get the whole number and multiply it by the denominator, 2 times 4, which is 8, and then add the 1, which is 9. So 9 over 4 and 2 and 1/4 are the same thing. And then with this, we times it by 100 over 1. This would be 900 over 4. And we're going to see how many 4s go into 900. 4 into 9 is 2. So 4, 8 with 1 remainder. 4 into 10 is 4, 8, 2. The 2 remainder. And 4 into 20 is 5. So this as a percentage is 225%. Now if you look at this and you think, hey, why is this over 100? That's because there's this 2 at the front. Okay, as soon as it hits 1, it's 100%. 2, it's 200%. And 1/4, well, that's 225%. D, I'm just going to put on the bottom here, 2/3. Now 2/3, if you remember, you can see from the table, we knew that 2/3 is the same as 66.6%. Again, if you want to be able to do this, we just times this by 100 over 1. This is equal to 200 over 3. And we're seeing how many 3s go into 200. 3 into 2 can't work. 3 into 20, 3, 6, 9, 12, 15, 18, 12, 5, 6. 2 remainder, 3 into 20, 6. And this is where you get that recursion happening. 6, 6, etc., etc., etc. So this is going to be equal to 66.67% when rounded out correctly. Just in case you're getting a bit lost with all these notes, because it's getting a bit squishy admittedly, I'll put a rectangle around the proper solutions. Alright, and lastly, we're going to convert the following decimals into percentages. Now this one, in my opinion, is the easiest one, because all you need to do is times by 100 or move the decimal point to the right twice. So 0.458, we're just going to move this decimal point to the right twice. 1, 2. So this is equal to 45.8. And remember, it's a percentage that we're after. 45.8% is our final answer. So here you can see in the previous examples, there's all these lines that you got to work out with a little pesky division. Here you just, let's just move the decimal point to the right twice. And that's what we did to get it in a percentage format. And the last one, before I show you which questions you need to do, 17.5, move the decimal point to the right twice. 1, we're at 175. Again, we are at 1750%. Now that seems like a big percentage. Remember, 1 is exactly 100%. So 2 has to be 200%, 3 has to be 300%, etc. all the way to 17. So 17 has to be 1700% at least. And because of this 0.5, that's where that 50 comes from. So it's 1750%. And that's it for this. I was expecting this for 25 minutes, got another 20 so far anyways. Let's have a look at what questions you need to do. So according to the weekly planner, which you should be able to find within Compass on our first lesson for the week, 3G, converting fractions, decimals, percentages. Our body tells us which questions you need to do. This is exercise 3G, questions 1 to 8, or 2 left-hand columns. In other words, exercise 3G, which is 153, the page 153, 1 to 8, or 2 left-hand columns. So unless it's 1 left-hand column, so it'll just be 1 over here, 2 these 2 left-hand columns, 3 these 2 left-hand columns, etc., all the way to 8. Now bear in mind, with this exercise, we've got this lesson, period 5's lesson, and then we also have the double on Wednesday's lesson, period 3 and period 4, to work on this as well. Okay, so I've pulled the brakes a little bit regarding the exercises and how much work is expected, because I'm not too sure how long this lockdown is going to go for. So let's just work on this exercise for 3 lessons. I'm going to put another side note as well. The exercises that we have been working on, I'll make the ones that we did last week be due by Friday. How you're meant to submit this work is just send me a picture of your work through the Teams chat system. I'll be able to look at this, make sure you correct it using the back of your textbook or the solutions provided on Compass, just to make sure that you are approaching your work correctly. And if you've got some answers incorrect, you can ask what's been going on or what you're doing wrong or what misconception you do have. So make sure that you do have that work in by the end of this week, Thursday, because I don't work on Fridays. Just send a picture of it through Teams. Anyways, that concludes this video. I'll see you guys in the next video for exercise 3H. Until then, stay safe, wash your hands, and I'll see you soon. Bye-bye.